Okay, with solving equations. Solving equations, we have to, the whole key to solving equations is getting the letter by itself. Whatever the letter is. In this case, it's a W. But the whole key, it's just like peeling an onion, or I kind of like to think of peeling a, not anchovy, but what are those things called? Oh, I'm losing it. Where we peel them back and you take the leaves off and you eat the pieces on the leaves, but you get into the center, the artichoke. Okay, so you want to get to that center. You want to get to the goodness, right? But to get to the goodness, I got to peel off, you know, the spiky leaves until I can get to the goodness. And even when you get to the goodness, it's covered with all this flowery crud that I have to peel away from it, you know. So, so the best thing is it's one step at a time. So, with this one, it's PEMDAS is done. There's no more PEMDAS for this one because there's just a variable plus a number equals a number. So, when PEMDAS is done, what that means is I don't have to add numbers to numbers. I don't have to add numbers to letters, or you know, or multiply anything through or anything like that. Basically, it's down to this three-part system, and now I know I'm solving. Now I know I'm solving. Okay, and once I know that I'm solving, because I got two pieces attached to the variable, then the solving technique is to take PEMDAS and go in reverse, and it's called SAD MEP. Okay, so we're just going backwards. So solving, SAD MEP. And so I go subtraction, addition from left to right. Okay, and what that means is I'm going to do the opposite of what's happening to the variable. Okay, in whatever is being added or subtracted to the variable, I'm going to add the opposite. Okay, so I'm looking at the variable and I see whatever's adding or subtracting to the variable. Okay, and in essence, remember, adding and subtracting are the same thing. If I want to take, say, W minus 3, it's the same as saying W plus a negative 3, right? Those are the same thing. So a minus and is the same thing as adding. It's just adding a negative. That's all. So all I'm going to do is look at what I'm adding to the variable, and I'm going to add the opposite. I'm adding a positive 8 to the variable, so I'm going to add a negative 8 to get rid of it. But what I do to one side, I have to do to the other side of the equation. And that's something you'll hear me say over and over. What you do to one side, you got to do to the other. Just like when we do our fractions. What you do to the bottom, you got to do to the top, right? Same thing. We got to keep this equation balanced. And to keep it balanced, what I do to one side, I have to do to the other. And the reason why I always add is because adding is so much easier than subtracting. Because think of it like this. Remember when we have those negative 7s and then we say, well, I'm going to minus a minus 7. What? I'm going to minus a minus 7, right? So sometimes it's easier to just think of it as always adding. Now some people think of it as just do the opposite. If it's adding 8, you're going to subtract 8. And that's fine too. Okay? But what you do to one side, you have to do to the other. Okay? So I've got adding a negative 8, and I get 0 here, so these go away. So all I'm left with is 5W is equal to, and negative 8 plus 3 gives me how much? Negative 5. Okay? And when I'm adding it, it's easier to see that. Sometimes when we're subtracting, like I said, if we had a negative 7 and I subtract 3 from it, a lot of people are going to see that as 4. And that's not 4. That's negative 10. Right? So, but when I say I have a negative 7, and I'm going to add a negative 3, when you look at that, you think, you know, more people than here think this is negative 10. So that's why I'm sticking to my guns on always adding the opposite. Okay? So here we are. We've got 5w equals negative 5. And so we did the opposite. And now we move to the next spot. And that is addition, or multiplication, division. Actually, division, multiplication from left to right. And so with this, what a lot of people say is always do the opposite. So if we're multiplying, we're going to divide. Alright? So in this case, if I'm multiplying by 5, whatever's happening to the variable, I'm going to do the opposite. So since I'm multiplying by 5, I'm going to divide by 5. But what I do to one side, I have to do to the other. And so now I get 5 goes into 5 and it should cancel out. So now I'm left with w. And then 5 goes into negative 5, negative 1 times. And so now I know that w is equal to negative 1. Okay? But in the same aspect as that one, sometimes you're given a problem like this where you have a fraction. And that's why I'm going to adjust that whole, if you're multiplying or dividing, by just a little bit. So when you have a fraction, we'll do a little different than just do the opposite. We're going to actually multiply always. And so let's just start again. We got solve SADMAP. Okay? So subtract, whatever is adding or subtracting. So, and I know that this is really adding a negative. It's adding a negative 1. So I'm going to add the opposite of negative 1, which is 1. But what I do to one side, I have to do to the other. So now I cancel these out, and I get 3/5 w is equal to 3. And at this point, I say, well, normally, if I'm dividing by 3 or multiplying by 3, now I got to divide by 3. So let's think about that. Taking this and dividing it by 3 could be kind of troublesome, right? If I'm dividing by 5, then I might as well do that first, because it does say dm. If it's dividing first, oh, I could multiply by 5 and get rid of it. So I could go 5 times this, and 5 times this, and then the 5's cancel, and I'm left with 3w equals 15. And now I do the opposite here, and I say, well, divide, because this is multiply, so I'm going to divide by 3, and I get w is equal to 5. Or we can step it up a notch, and we can do the same thing. 3/5 w equals 3. We can do the same thing, except multiply by the reciprocal. 5/3. Just take it, flip it, and multiply it through. But what I do to this side, I have to do to this side. 5/3. And remember, that's 3/1. And so now it's 5 times 3, which is 15, or the 5's cancel and the 3's cancel, and they cancel out, and I get w. And then these 3's cancel, or I get 3 times 5 is 15, divided by 3 is 5, right? Or the 3's cancel, and I'm left with 5 anyways. Now, it's up to you which way you want to do it.
The second one looked easier.
I like the second one.
I remember that.